Hello everyone. This is the second session we have in Advanced Database course. Professor Mahmoud told me that there are a few number of undergraduate students who are taking this course bravely. Could you please raise your hand if you are undergraduate? Okay. One more question is that was it so fast last session or time? Repeat. Did you understand what, how was the course, how was the last?
Last night, it was fine.
Fine?
Yeah.
Are you talking about with the other teacher, with the other professor?
Yeah.
What?
We made it to the other professor. Like,
Oh.
the schedule changed just after.
Oh, I see.
That's why we weren't here.
Okay, no problem. Okay, that's great that you have undergraduate students also. I hope that you enjoy the class. Today we will have a brief review on entity relationship model and entity relationship diagrams. We will have a brief overview on the database design, and then we will show how to ER diagram could be, how ER diagram can be translated to relational model. So, what we did last class was we had an overview on what did we study last?
Schemas, database schemas.
Database schemas, different database levels, abstractions. We had the overview
Jobs of DBMS.
physical layer, physical level, then the
About the DBMS, about the jobs.
right, and the job of DBMS and the all conceptual level, and also we considered external level, and we saw a few examples. Today we will start with database schema and designing the database. So, what is this schema used for?
To use it at a higher level of abstraction.
If you want to have a database, you have to design a database, okay? And this database schema is basically the sketch of the database, the design of the database, okay?
Blueprint.
So this is the earliest stage of developing a database. Similar to other engineering branches, you always have designing, you always have to design something and then implement it, okay? You're not going to build a house without any blueprint, without any map and plan. So similar to other engineering projects, you start with designing, and the goal of the database designing is a specification of database schema. So now the question is how we can specify this database schema. Suppose that you are going to a company, you are hired and you are asked to, not a database, but you are asked to develop a software for them to do some tasks. So what do? The first step.
Requirement analysis.
You
Get the requirements.
You go and do research and see what they need, and the requirements are analyzed. First, similar to other software projects, you also have to have a brief requirement analysis, and then based on that requirement analysis, you build a model about the essential component of enterprise and how they are related. Okay, so now let me bring you a simple example. Suppose that you are familiar with registration system in the university, right? So could you please just name a few essential components of this system? Essential component of a registration system. Essential component of the task of registration. What?
Oh, the courses.
Yes, you have to know about the courses. Okay, this is the first element. Times are, if you separate the element of courses, And then you have to know about sessions and schedules of classes, okay? Then you have courses, concept of courses.
Students and process.
Yes, students are also another element of this system, because if there is no student, there is no registration, okay? And then, what else?
Each term.
Service and spring is not very separated from the schedule of the courses, right? The schedule of classes, because the schedule of class
Location.
essentially what?
Class location.
Class location is a part, again, some part of the component of classes.
Fees.
Fees, exactly. Fees and money, things. So, and all of this, these are essential components of this system. No, now, after building a model, we design a relational entity relational model. Then we use this entity relational model to build a database. So, what is an entity relational model? What do you do in software engineering usually? When you want to develop a software, you start with designing. What do you do?
Create a blueprint.
Create blueprint, create some diagrams. You design through specifying classes and objects and everything through diagrams and shapes. Why diagrams are useful? Because they are easier to understand. Okay. Similar to software engineering, in database design is also we are doing the same thing, except we are using a specific approach. It's called entity relationship model. So, in our technique, basically we went to the enterprise, or let's say this registration system, and then we select out the main components, major components, okay, essential components. Now, in addition to the components, what do you need to specify? You know that there is a component of courses. You know that there is a component of a student. It is an essential part of the registration. Now, it's time to specify the relationship between student and courses, okay? Then you have to specify what the students are, how students are related to the courses, or how students are related to the professors, or how professors are related to classes and sessions. So the first step in building an ER model is viewing the enterprise as a set of entities and also relationships between those entities. What are entities? You mentioned right now in your example. For example, student is an entity. Okay, so the student, the concept of the student as an entity. Entity is basically, as seen in the slide, an object that is involved in the enterprise. Basically, for example, Fanindra or the course number CS551 are two objects, two entities. Okay, so you go to the enterprise, you go to the system, recognize all of these enterprises. Okay, like for example, you have a set of people called, you have a set of people like Reza or Professor Mahmoud or other people who are teaching courses. Also, you have your friends. All of the system is composed of these people, and also you have a set of courses. Then, out of these entities, you have to recognize the entity type. You have to recognize how these objects are related and the similarities between objects. Okay. For example, you consider the file of your friend Fanindra and also Matthew, and then you realize that all of these students, all of these objects have same attributes and same fields. Therefore, the concept of these objects have a single entity type, and you can recognize this entity type. Okay. So, in order to recognize an entity type, you have to recognize the similarities between objects. For example, in this system, we recognize the students and courses as entity types. And then after recognizing entity types, we have to recognize the attributes, the fields and the attributes that we have to save and store in our databases. So the entity type is the principal factor, as you saw here until now, the principal factor in designing a database, okay? If you fail to recognize entities and entity types, then definitely you are going to the wrong direction, okay? So each entity type is also described by a set of attributes, as I mentioned. Like, for example, a person is in the system is described with the ID, name, address, and hobbies. After specifying attributes, what we should do? What should we do after specifying attributes?
Set the domain of the
What is the domain? What do we mean by domain?
category. At what range does the attributes fall in?
Suppose that you are writing a program, okay? When you are writing a program and you are deciding about the variable, what do you do in computer science?
Data
You decide what type of the variable is, okay? Specifically, when you are deciding what type of the variable is, then you are implicitly specifying the domain of the variable, okay? If the variable is kind of integer, there is a range that integer numbers can cover. If the variable is float, there is a range that float numbers can cover, okay? Here, same here. You have to define these domains. In addition to that, in the databases, domains are playing a more important role. Why? In developing a program, in writing a program, you are specifying the type of the variable in order to let the computer know how the variable should be stored. Okay, if it is an integer, there is a standard for storing and retrieving integers and manipulating integers. Okay, but in databases, in addition to show that how the information should be stored, also you put constraints on the variables. Okay, the domains here is not only the type of the variable; the domains are also possible values and attributes. So at this moment of designing database, for now, you can assume that a variable and an attribute can be a set. Okay. Here, for example, I show the record of a student. His name is John, and his ID is 11111, and the address is 123 Main Street, and his hobby is stamps and coins. Okay. You see that here, the domain is also the variable. The hobby is the attribute is a set. So basically, attributes describe one aspect of an entity type, and after defining domains for attributes, the next step is specifying keys. So why are we specifying keys? Why?
to access them easily.
Uniqueness. Why do we need uniqueness?
Data from one
Or another. Okay, what we don't have what differentiation.
while searching it in WPS.
Suppose that in the records of professors you have Professor Mahmoud twice. So
To access them easily.
what?
It will be ambiguous while searching.
No, but when you search and you select the records, then Professor Mahmoud will come out the row Professor Mahmoud twice, and then you see twice Professor Mahmoud. We are so glad that he sees twice.
Uniquely identify a particular record, and to merge them with the others, you need some key to identify the proper entity.
Yes, but key is not only for the uniqueness. It is put
For relation?
This is not what?
For relation.
Relation of
Relation
what?
between tables.
To merge with other table, we need the unique key.
Okay, you are getting close. So key is some sort of configuring the relationship between entities. Okay, you mentioned that Professor Mahmoud should appear in the table of faculty just once. when you select it, if you see Professor Mahmoud twice, it will be more glad, you know. But if we are going to compute some factors for Professor Mahmoud, for example, if you want to give him some salaries, and this redundancy exists, then we will face the problem later on. Okay? So the first role of the key is removing redundancy and make the computation of the results of the query correct. Okay? There is another role. What do you think about that? Why do we need to find out which attribute is unique and can identify a record? You mentioned that this uniqueness is helping us
Merge the data
to
to
compute relationship between entities, okay? So why is it important that it should be unique?
Because otherwise you can't compare between two tables with the redundant data.
You can compare.
When we want to join two tables, we just need a single key.
You need a single key. With that key, not only plays an important role in the correctness of the computation, it also it is required for the indexing and database internals, right? We know that databases are invented to facilitate and accelerate the computations of the requested information, right? So that key is also required to be recognized. So the key is now to define the key as the minimum set of attributes that uniquely identifies an entity. So then after defining all of these parts, we got entity schema. The entity schema is basically the entity in the type name, attributes, and key constraints. So we draw an entity like this. For example, the entity of person is shown here. The entity name is here, and the attributes are shown as oval shapes.
So, is the whole thing called the enterprise? Is that what it is?
The entity part of the diagram.
So you need to do the
No,
enterprise?
we are developing it.
Okay.
No, we are adding it. If we could make a database from this, it would be great, right? Easier. But no, we need more stuff. Note that here, this double line shows that hobbies could be a set, okay? This is a set value. Now, time to relationships. Okay, you mentioned that the main part of the information is entity types and entities. Okay, but these entities are related to each other. Okay, and this relationship is part of the system information. So we need to recognize that relationship as well. For example, the relationship can be between two different types, different entity types. For example, the first sentence says that Reza works in the Department of Computer Science. Okay, suppose that the Computer Science department is one entity. You have different departments. One entity type is the department of the department of the university. The other entity is Reza. The type of this entity is student or staff, and there is a relationship here called works. Okay, so this relationship can be recognized. The relationship not only can be defined on different types of entities, but also it can be defined on the same type of entities. Okay, recursively. Suppose that you can define the relationship of liking people or disliking people or hating people. Okay, for example, here I mentioned that David dislikes Andy. Both of these entities are, for example, students or person. Okay, this is a round relationship on the same type. Could you bring one more example of a relationship on the same entity type?
car is faster than another car.
It's exactly. One car is faster than the other car. And more.
Professor work for department.
Professor work for there are two different types of professors. Not that type.
Comparing IDs.
This department have more courses
No,
than that
comparing
department.
IDs, phone numbers.
Comparing. No, but we are comparing our needs, not a relationship between, right? The relationship of speeding was one relationship, but comparing IDs is not useful, is it?
Family names.
Comparing the salary.
No, we are not doing an action. We are defining relationship between.
Yeah, student should
one
register
entity.
some courses.
The other type of relationship is marriage. Okay. On the entity type of person, one person can marry another person. Okay. So this is another type of entity relationship. So similar to after recognizing relationships, we have to take out relationship type out of those relationships. For example, here from the above sentence, we can extract this information, the faculty type, entity type, related to the department entity type by relationship works in. So, what are the elements of relationship? A relationship can have attributes, right? For example, here in this example, Reza works in the Department of Computer Science since 2016. Okay. Give another example, please.
The same, the one car is faster than another car by certain mile per hour.
Yes. Or
The one person is married to another person since certain years.
or one person married to another person in this temple or church. In addition to relationship type, in addition to attribute, we have to recognize roles of the entity types for a relationship, okay? Here, for example, in the example I mentioned above, Reza is the value of faculty. Then we have a faculty role in the works in relationship. So, and also, Department of Computer Science is playing the role of department in this relationship. So, give more example. In the marriage.
So the two persons are attributes and the marriage is the
The personal attributes and the marriage is? No.
Husband is a role and wife is a role.
Husband is a role, wife is a role. Okay? Marriage is the relationship. So, again, relationship type is also described by attributes and roles. Note that the role name of the relationship is not necessarily the name of the entity in the entity type in the relationship. Okay. For example, here in the example I mentioned, we had the entity of faculty, we had the entity of department, and we put the same name for the roles. Okay. But for the marriage example, we can distinguish between the roles by husband and wife, right? You are putting a different role than what the entity name is. So now we define a relationship type schema in terms of roles and attribute names, and then here again we define a key. So you'll see why we define the key. probably the same reason. The minimum set of roles and attributes that uniquely identify a relationship is the key. Okay? For example, for the faculty and department relationship, what would be the key?
Department ID.
Engineering department.
Department ID cannot uniquely identify the relationship. For example, you have Department of Computer Science. Okay?
Yeah, like both has like computer science department
Faculty
and
who is
faculty.
working from 2016.
Yes, the set of faculty and department are attributes. Okay? Okay, you mentioned that role name is a part of the key, but note that when you are saying that faculty ID or department ID is an attribute for another entity. You should say that faculty or department. Okay. From when you are considering relationship, you are not considering it from point of other entities. Okay, this is one example of ERD diagrams. Finally, we get this. So, this is the question you asked. This is when we are adding, for example, here professors and departments are working relationship with department of the value of since, or students are enrolling in some programs since some time. Employees are related to each other with this relationship of subordinated or supervising, and also here the marriage. Okay, so now one question. As you see here, relationship is here, and this is an entity, and this is an attribute of relationship. So why is this arrow is thicker?
Because the professor works in the department.
Suppose that we put this constraint that each professor can have only one department. Okay, suppose this rule is activated. Then, if this rule is enforced, then in the relationship of works in a department, we don't need to put department as a part of the key. Why?
Part of departments.
What?
Professor can have many departments.
Yeah, each professor can identify the role in the relationship, okay? Each professor can identify the relationship inside of the relationship diagram. So, in this case, we put this sign, arrow, figure arrow over ER diagrams.
This is a one-to-one relation, like is relationship, one-to-one.
Here, between yes, if professor is key in the part works in, it will be one-to-one. One-to-one from the professor, but from the department who works in, men-to-one, right? Oh, by the way, this is an example of two-way relationship on the same time. So, okay, now I would like to define a constraint, which is called participation constraint. Okay, if every entity participates in at least one relationship, a participation constraint is holding. Okay, what does it mean? Every entity participates in at least one. It means that, for example, in the entity, in the relationship of faculty department, if we have participation constraint for faculty, it means that every faculty should have at least one department. Okay, and the relationship to departments should be the same, should have the same number of roles as the entity of faculty has. So, okay, now another interesting feature between entities. One entity type might be subtype of another. Okay, how many of you are familiar with inheritance? Almost everyone. Okay, very good. So here we are still considering the generalization relationship between entities. For example, here faculty is a subtype of staff. Then there should be some kind of relationship between faculty entity and corresponding staff entity. This relationship is in databases is called is-a relationship. Okay. For example, an is-a relationship is shown by this sign in the entity ER diagram. For example, here we show that faculty, secretary, and librarian, all of them are staff. So, again, similar to programming, we can have defined inheritance here. What does it mean, inheritance in databases?
All the attributes of like base attribute, like base role comes to the subtype role also.
Right. If a faculty is a staff and a staff has a staff ID, then faculty should also have a staff ID. Okay.
But the
So-
subclass can implement more attributes.
A specific class, yes. For example, faculty could have a degree or a specialty, but the staff, the general staff, for example, secretary doesn't need to have a specialty. So the first thing is that subtype is, as you mentioned, subtype inherits all attributes from supertype. Also, key of the supertype is the key of subtype. Okay, if you can identify a staff with a key, if you can identify me as a staff with a key, that key could be used to identify me as a faculty also, right? Okay.
But it does not hold.
Okay, so suppose that my staff ID is X, okay? If you go to the table of the faculty, you can find me with a staff ID of X, okay? In the table of in entity of staff, I am recognized with X. If the same keys apply here,
Can we set up a different key as well?
yes, you can directly define different keys. Okay, so the more important feature is transitivity. Transitivity basically is a relationship creates a hierarchy of entities for you, and it's a kind of tree-style hierarchy. And transitivity shows that, for example, between is a relationship can use to infer and develop more interesting is a relationships. For example, faculty is a staff, the staff is a person, then faculty is a person. You can infer and go and directly infer more information about the staff. For example, here you can see three of entities shown in this hierarchy by is a relationship. The faculty, secretary, and librarian is a staff. The staff is a person. The student is a person. Okay. If you define a person ID, here in the University of Bridgeport you have an ID, right? All of you have an ID. You have an ID number. I have also ID number. Okay. Everyone has ID number. So that ID number is assigned for person. Okay. So, but I enrolled in the payroll. I have paycheck. Also, the secretary department also has a paycheck. And this is a picture of staff. Probably students don't get any money, so they don't have any. Or students are paying money, so they have this
Pay account.
bill for the payment. So basically, And why are we using is a relationship? We could skip it, right? It doesn't matter, you know, it's a relationship between different entities. Right. Why are you using inheritance in the object-oriented programming?
To less the burden, reusable to less the burden.
What?
To less the burden, for reusability.
We can make
Can
more
you explain
generalized
more?
Abstraction.
It brings you an abstraction. Why are we using abstraction in computer science? Why are we using abstraction? It's last session we discussed about it because abstraction makes it easy to understand. Okay?
Everyone
You-
like need not to have access for everything. So
Right. So first of all, it makes it easy to understand. Second point is that you don't need to set different attributes for different tables. For example, suppose that you need to have an entity of person for all of the people on the campus. You need to, police department needs to know some information about all of the people, okay? So they have this table of entity. Reza Basreda has this ID number, and that's it. Also, payroll has the same entity for staff people, okay? Again, they are storing my ID, my name, my last name, and blah, blah, blah. Okay? If they have the same entity, they can shade it. The police department can add, can have its external entity as a like security status of a person, and also the other person can be referred as a payroll member.
First. So the entity, the set of data, was it?
Everything is
The
set up.
person.
We are recognizing data, okay? But entity is an object involved in the system, a separate object, like a person. Entity type is a person, like you are an object, right? But your relationship between other people also, your relationship between the core system, the registration is also data, right? So now,
Where's the entity coming in? That's what.
what?
I can't figure out where the entity.
And if you go to a system as a programmer and consider the system, do the requirement analysis, go and search how the system works, you can understand that the system needs, for example, a student as a part of the system, okay?
Mm.
So the name of the entities are extracted by doing research and checking the process of how the work is done, okay? So first, you go to the system, recognize the objects as entities, recognize their types. Okay, student type, faculty type, course. Doesn't matter the object is physically existing or logically existing. You don't have any object of course, right? Course doesn't have any weight or volume or anything or color. The student has it, you know. A student has weight or shape, but course doesn't. But when you go to the system and search for the objects, we mean that virtual objects or real objects involved in the system. Okay, you go to the system, extract the entities, then extract the relationship between entities, then you extract the is a relationship between entities. Okay, and then this is a relationship between entities are helping us to set different common variant attributes from the different entities. Also, they are used to grouping of attributes in one place and the other place. Okay, you group all of the attributes required for staffing and for payroll in the staff entity. However, there is another entity related to this entity called person, and the same information is held over there. And also attributes of civilian terms can be different. Okay, now bring a piece of paper and your pen, and we will have a crossword. Draw an is a hierarchy of university attributes have 4 entities. Slide. So there are two types of, you can define two types of constraints on either relationship. One type is covering constraint, which means that union of subtype entities is equal to set of supertype entities. What does it mean?
An entity can have more than one role.
One more time, Professor. Question.
Second thing.
So, for example, here, you cannot see. Go to this diagram. Here, for example, covering constraint says that all of the union of subtype entities is equal to the set of supertype. Okay, it means that faculty, secretary, librarian is a staff, and there is staff is no one else. Okay, whoever is the staff is part of this. Should be part of this. Okay, then it means that this is a covering constraint. There is another constraint, disjoint constraint. Sets of subtype entities are disjoint from one another. Okay, what does it mean? Simpler.
Faculty type cannot be student type.
Faculty cannot be secretary. The secretary cannot be librarian. Okay, this is a disjoint completely. So, okay, now we have 20 minutes to show how this entity type and relation type can be translated to relational model. Okay, you remember the relational model we had for the database. We had the relational model where the information was stored in relations, in tables. Okay, now we want to translate entity types to ERD diagrams to relational model. For example, here every entity type corresponds to a relationship. This is a question that you ask. You ask that every person is a table. This is not table. We first recognize the objects and entity types. Then now we define what kind of tables we should have in the database. Okay. So every entity is a table. Relations attributes are entity types attributes. Okay. Then you know how to define the fields of the tables, the columns. Okay. So the question is now, what if entity type has set value attributes? How do we resolve this? You remember John had 2 hobbies, coin and a stamp. How do you represent this in a table?
We'll give ID in one table and we'll have a separate table which has these hobbies separately. Hobby 1, hobby 2, hobby 3.
This is normalization. We are not getting to normalization yet, but one way is showing John in 2 rows. One John with the ID number 111 with the address 123 Main Street. The hobby is coin. The other row should be 1 John 1111 John, the address and also a stamp. Okay. So, but this is one approach, right? And it works, but it's not a good solution because redundancy. Suppose that John changed his name to Andy, then you have to go to all the rows, find John name and change it to Andy. Okay. And then again, the key of the relationship will be changed. Okay, then now 1111 could not be a key. Why? Because there are 2 rows assigned to this. Solution is normalization, as your friend told, and we will get to the normalization next week. Professor Mahmoud asked me to put more time on normalization. because he thinks that it's very more important and I have to spend more time on it. Okay, so now what's going on? What's the story with relationship type? We did a lot of work to extract relationship type. What should we do? Should we throw them in the garbage can? No. They are also a type of information. They are also a type of information that you have to save. So again, relationship becomes a relation in a relationship type becomes a relation in the relational model. Therefore, for each relationship type, you define a table. Okay? You told that, for example, each faculty works in department. Okay? You have a table for department because of the previous slide. You have a table for the faculty because of the previous slide. You have to have a table for faculty department because of this slide. Because of this rule, a relationship type becomes a relation in a relational model. And moreover, attributes of corresponding relations are the same. So, for each role, the primary key of the entity type associated with that role. Now, you mentioned that the department ID should appear in the table, right? So, exactly this is the solution. Now we decide that we should put department ID in the table as a key, as a foreign key. So, for example, here, if we want, I mentioned the example. For example, here we will have a table for professors, a table for department, a table for works in, which has, how many columns does it have? How many columns? Three. One is for faculty, showing which faculty it is referring. One is for the department, showing which department it is referring, and one is the date that they are starting to work. So,
working, what are the attributes for working?
we recognize this since when it joined, or it can be location also, it can be office, some other attributes. So candidate key of a corresponding table is a candidate key of a relationship again, and attributes of the corresponding relationship are the same except set values, and we will see what's the story with set values. Okay, now representing is a relationship. How do you represent it? The best way is that supertypes and subtypes can be realized in different tables. Okay? What do we mean by that?
For staff we have one table, for faculty we have one more table,
Yes, for staff we have one relation.
faculty we have one more.
We have one more. But in the staff table, we store all of the information shared between the staff, faculty, and librarian and secretary, okay? For example, name, address, picture for maybe. But in the faculty, you specifically store the information just related to faculty, the attributes of faculty entity. What are the attributes of faculty entity? Specialty, the university he was graduated from, and like, for example, other types of the information. So, how do we identify a subtype from the supertype, subtype entity? Okay, so as mentioned, the person has a personal ID in the university, okay? That key goes through all of the subtypes. And from that key, from the subtype, you can use it as a foreign key, and you can find the person inside it. For example, you have my personal ID. When you have my personal ID, you can see my information in faculty. You can find it, that my degree or the university that I graduated from. And then you can use the same key as a foreign key to the main relationship and find, for example, my address or other stuff. What is the benefit of this? It eliminates the redundancy. Okay, so today we learned how to design a database using an ERT diagram. Now we draw an is-A hierarchy as a classwork right now. Please draw a simple ERT diagram for a car selling, so car dealer. You have 10 minutes. You need to have at least 3 entities.